community,
Yeah.
Scala community, that we, at this point we shouldn't, if we don't do this, maybe seen as something negative. But
Okay.
So
Just making sure to like maintain the relationships and
yeah, it's very
visibility. Okay.
Okay, I think it's time to start. Welcome everyone to ScalaWAW, number 34. After a short break, I'm Łukasz, I'll be your host today. And this is very much a one-man operation, so if you would like to help, I'm always looking for help, either with like coordination here at the event, or like refining venues, or just marketing, scouting for speakers. I'm open to anything, so if you'd like to help, just contact me anywhere. So before we start, I'd like to talk about what's coming next. So I'm planning a hackathon in June, maybe. We'll see how it works. And of course, in July, we'll have our annual beach party, which is, I guess, a highlight for everybody attending regularly. So in August, there's a special event that I wanted to tell you about, Scala Days. So if you haven't heard about Scala Days, it's the most important Scala event. And it's a great opportunity to learn about cutting-edge developments in Scala world and meet other Scala engineers. Get to know companies that use Scala, because that's the place where companies should advertise if they use Scala. And of course, support the community in either by being present and just show you are interested in Scala, or in any other way. I've been in Lausanne, where the conference takes place in 19, and my experience was fabulous. I really enjoyed the community. I was able to see the birthplace of Scala and also the famous Scala stairs that you can see on the right. And it was a great opportunity to spend my training budget, because it's in Switzerland, so yeah, no better place, I guess, to do that. And like, my recommendation, if you are unsure about going, or you want to go, take a week longer and just go around Switzerland. It's so beautiful, and you can have a really fun time, like hiking or looking at beautiful landscape, and then of course enjoying Scala. So for today, the plan is simple, and I guess since you are here, you know the plan. We'll start with a presentation about IntelliJ by Maciej. Then we have like a short networking break that will take place in the back of the room. And then Haoyi will talk about meal build tool. After the presentation, I think we can meet downstairs at the bar. Like, it's directly downstairs. And that's the plan. We usually try to be flexible, let's say. So this time here might not be accurate. Sorry about that. Few last things. If you would like to tweet or whatever you do now on Twitter, on X, sorry, that's our handle. This event is live streamed, and last but not least, please give a round of applause to our sponsors, JetBrains and iterators, as you can see. There's some swag in the back. Okay, so without further ado, Maciej, I invite you to the stage.
Okay. I don't think so. Oh, this is only going to your recording. Okay. So, hello everyone. My name is Maciej. I'm a product marketing manager in IntelliJ Scala Plugin. Like this. And today I'm just going to try to some live coding in IntelliJ IDEA with Scala Plugin. So first of all, you may notice some glitches. This is expected, especially that we are talking here about the Scala free support for in IntelliJ Scala Plugin, which we are pretty good at already, but we are still working on at some things, and I'm exactly going to talk about those things. So yeah, there will be a lot of details that may not exactly go according to the plan. I hope I will have enough time to fix them. And anyway, if you want to see something more than just my presentation today, we have a YouTube channel, IntelliJ IDEA, and there's lots and lots of different videos here, lots of them about other programming languages or other tools, but you can see also those red, violet ones, and these are all from the new series we have, IntelliJ IDEA X Scala, and we are starting to promote and talk about the different details of IntelliJ IDEA when you want to use them to write Scala code. There's IntelliJ IDEA is full of little features, little quirks that can help you, and there's probably no better way to talk about them quickly than YouTube videos. Like each one of them is about 10 minutes long. Yep. So. This is the code. Let me know if I just, I don't know, write something. Super power level val name, let's say, string. Let me know if this is readable to everyone. Should I make the code bigger, like the font bigger or something? Or is it all right? Okay, I will be also using AI chat here. This is mainly for, oh, maybe I can use it even more than this. I can just go to completion, code completion, yes. Enable, no, this one not, but I have Scala here complete. Okay, inline also. Okay, everything should be set. The only problem is that probably the Wi-Fi here is not that good, so maybe my AI-based code completion won't be that as fast as I would like it to be. So we will talk today about enums, then about indentation-based syntax, so how IntelliJ Scala plugin can help you with all those, like aligning your lines of code if you don't like braces. And then about named tuples, a new feature that is was standardized in Scala 3.7. So at least for the indentation-based syntax, I need to write some code to show you how it works, because on an empty file there's nothing to do. So we'll start with an example that I will just try to expand on it. So we have a enum. This extends superpower level, and this is weak, right? Same. Thank you. Same. So yeah, I'm a bit showing off here, but this is to show you that even if you don't, even if you don't expect a certain level of help from your AI assistant, even this is much faster than what you can do manually. Otherwise, I would have to do a lot of copy-paste. So yeah, that's already a bit of productivity, from IntelliJ Scala plugin. Okay, and we have a val name, and we can now go to here and create a main method using the template. So this goes like here. So you can go to Scala, for example, also many others. And here I have a method main that looks like here, that if I just type main, then Scala plugin will tell me, okay, I can just do it for you. And there are many others that simply unapply, for example, that also can be pretty useful, and you can add your own. So if you have if you find yourself writing code that is just boilerplate, and you use the same code a lot, you may think about adding it to live templates, and then if I just do it once again, if I just write main, then IntelliJ IDEA will recognize that maybe I want to do this like this. Okay, let's just print the values. to see if everything's fine. This is an old laptop. Compiling. Yeah, because this is just values as some kind of an array. Let's do it like this. Yeah. Okay. So what we can do here? We can, for example, do level or Hulk, okay, and then do Hulk match. And since enum is basically under the hood the same as a sealed trait with some case objects, then that we know all the cases already. We can just Scala plugin offers to do it the match for us, and just generate all the cases. So let's leave it like this for a moment, and instead, maybe I'll just try to import. Yeah. Only let's remove this. Okay. We can also do something like object super level power. Like, okay, I did it before, so AI assistant already know what I want to do. So if I have a method in an object, companion object for an enum that is like has R in name, for example, for a given level, only strong has R in name, then I can try to write something like if, for example, yeah, that's also possible, but I would like to do if Hulk dot, and you can see that on the code completion here I also have this method, even though that should be like if it's done directly without code completion, that would be an error. Have R in name is a method of the companion object, but this is because only to like to make the whole code completion a bit shorter, and you should like everyone should already know what is it about. So if I just choose it, then this will be already like Hulk has R in name, but Hulk doesn't. Okay. We can also, like from the point of view of Scala developer, we have access to enums from Java in a very simple way as well. We can go just val month dot, and this just works. Like you in IntelliJ IDEA, under the hood changes both Scala and Java syntax into our PSI model, and they can communicate. So we have access to everything that is written in Java. We can simply access it in Scala. This is a bit more difficult the other way around, because this is not in our control, like as a Scala plugin team. But we can, for example, if I have already the superpower level here, and I do extend Java lang enum superpower level, extend yes. Then if I go here, I can just do var level superpower level module, and yeah, values, for example. It becomes a bit, if I wanted to just do one level, then now I can do it like this. But yeah, this is one of the glitches. This is now in red, even though we can, the compiler works. This shouldn't be an error here. But you can, but if you want to do it in a more like way that just value off, we can just, this works without glitches now. Anyway. Yep. So right, we have I'm already using the indentation-based syntax now. This can be, like the support for it can be turned on in the settings, editor, code style, Scala, and I should go to other. And here we have this use indentation-based syntax. This is now turned off by default, starting from the latest release to 2025.1, because we got feedback from developers that are migrating from Scala 2 to Scala 3, and they are saying that if this is by default, their code just turns red everywhere. So it's better not force them to turn it off, but just the other way around, that the braces are the default one, indentation-based is by if you want it. But also, for new projects, we can just have it here. Yeah, this is use indentation-based syntax can be just chosen in the project wizard, but that's not necessary now. Okay. So for these, to show you how we support the indentation-based, I need to create a bit more code here. Let's say we have a superhero class. A superhero has a name and a power level. And now let's say I have a method here, also on the main level up. But so level up will be a method that takes a superhero, and then if we can create a new level. This will be like a way to, yeah, exactly. This will be a way to take a power level of a hero, create a level that is bumped up one level, and then create a new superhero that has this new better power level. And now if I go here and create, for example, Iron Man medium, and then printline Iron Man and printline level up Iron Man. Let's just, what's going on? Error overriding. Okay, yeah, because this should be labeled really. Okay, let's just remove this part. Yeah, Java enums have a name field, so now I would need to. What will happen if I just write override here? Will that work? No. Okay. Okay. Yeah, so we got it. And code completion, and also you can see that we have this code completion for the end keyword. If I start to write end here, then Scala plugin will ask me if this is what I want. So in cases where you cannot be entirely sure if the indentation is enough to symbolize that this is a block of code inside another block of code, then you can also use the end keyword, and same here, and level up. Yeah, that works as well. But let's say, also, for the sake of just making this code a bit more complicated, that, okay, we can have weak superheroes turn to medium, medium to strong, strong to Hulk, and Hulk stays at Hulk. Hulk is the strongest there is. But let's say that if we have the real Hulk, not just someone on the Hulk level, hero name in this case must be the Hulk, then we want to change Hulk to weak again. Okay, so maybe let's do this a bit differently. Here we have val new level. This goes down. This goes here. And here we have weak. Okay, and only else. And you can see like else was already, if I hit return now, else is already recognized as a part of the if then. And then we have this hero power level but if we, under the condition that the hero we are talking again about is not the real Hulk. So what I can do, but you can see like this, even if I now probably try to run it, this shouldn't work because the indentation is completely messed up right now. Oh, it doesn't. Okay, but anyway, it is completely messed up. So what I want to do is to, of course, move it to the right. But if I do it like this in the simplest way possible, then this just moves to the right and to the left, the whole 4 lines, exactly the same amount of tabs, which is not entirely what I want. What I can do instead is to use Shift Control I, and let IntelliJ figure out how to do the indentation. So now it did it like the right way. But there are also other options which I want to show you. For example, we can do option X at the sum level. So option X and option Z lets you select some element. And then with another option X, this spreads out. We go to the whole line, to the whole block of code, then up and up and up. And this works neatly with this auto indentation, because you can just tell the whole IntelliJ, okay, I want like go up to the whole method. Let's try if it works now. Yeah, and then Scala Plugin will try to. Sometimes it has some problems, but it can often just make like put the indentation right for you. And if you want to go back, then option Z is just shrinking that selection back to where it was. We also have something that is called sticky selection. So if I put my caret, let's say here, and click, in my case, Shift Control Z, then I toggle sticky selection. And now just simply by using arrows, I can create a selection from the given point up and down. And Shift Control Z again, remove that toggle sticky selection. Of course, I don't want you to just remember all those shortcuts. Instead, it would be better if you just go to settings, to key map. I have my own custom key map because like 10, 15 years ago I used Eclipse and I just got used to the shortcuts from Eclipse. So now this is like some mashup of IntelliJ keys shortcuts and Eclipse shortcuts, what I use. But you can just go here, go through all the, like you can even learn more interesting small things that IntelliJ can help you with, and just create your own shortcuts for them and create your own customized key map. And I think that's much better than just trying to remember the default ones. One more nice little thing that I would like to show you is something that I use very often, but I don't see it much in the code by other people. So I'm just like, oh, do it. Please follow my example. What you can do is you can option and here, no, shift, probably with shift. Yeah, so I can clone the caret. And with a cloned caret, I can write the same code in more than one place. But here I'm not going to use it for that. I'm just going to use it to just align the arrows by itself. So just this here seems simple and is simple, but if you, for example, use for yield a lot with the left arrows, then you can have like a very complicated case where you have like many lines of inside the for yield with many flat maps in the middle. And I think that then using those like aligning those lines is makes the code much more readable. What else is that I can now, if I click on anywhere, then that cloned caret disappears. And what I can do even more is that I can go Shift Option and arrows and just move a block of code. Now I'm on one line, so it simply moves one line. But if I go, for example, here, then Shift Option will move the whole match case. So yeah, now this makes little sense, but this is also like a way where you can take something and move it up, and it will just like align with the indentation-based syntax on different levels. Yeah. What else? We can go to again to editor and Scala code style Scala. And look, we are here in the Other tab, but we can go to the tabs and indents. And as you can see, right now we are using tabs as a way to indent. And one tab is 2 spaces. We can also just disable it, and then instead of tabs, we will have just white spaces everywhere. Or you can also use something called smart tabs, which means that for like normal indentation, it will be tabs, but sometimes, just like what I showed you, like when I want to align code more carefully, then we can have those careful aligning done with white spaces. But let's not do it now, but instead let's just disable using tabs. Let's click OK here. So for now, nothing changed. Everything looks exactly the same. What happens is that this little button here in the right down corner now has this little asterisk here. And that means that IntelliJ recognized that we want to have indentation with white spaces, but what this file has is indentation with tabs. So it offers to re-indent it. Let's do it. And now this is just for reasons, and now it should be configure indents. Hop. So yeah, if I now write like new case, then this will be white space, but it didn't work here. Oh, all right, it should. Anyway, if I now go back to here, use tab spaces, okay. Yeah, all good. Yeah, this is one of the things that is still glitchy. Like in some cases, for example, you can move your code a bit up and down, and IntelliJ will not figure out correctly how much indentation is needed, and sometimes white spaces and tabs will not be transformed correctly as well. We are still working on it. What else? In this editor code style Scala is the wrapping and braces tab, and you can here see instead of doing the indentation manually, you can just force some rules that the code will and IntelliJ will then force them on the code for you. You can, for example, force braces. This is like the exact opposite. If you don't want indentation-based syntax, then you can just decide that, okay, we can try to have, if I write code, and even if I don't write a brace, then IntelliJ should put it there for me. So you can also have like a special treatment of else if. Should there be indentation and should there be else on a separate line, or should they be on the same line? And same with if there should be an indentation, if not the first element, the first keyword in the line. What else you can see? Yeah, you can do it also for while, do while, and so on. What else is interesting can be this indent arguments with columns, which is used for the fewer braces feature, because it makes IntelliJ indent your the inside of a method like this. And fewer braces in Scala plugin is really only supported in the way that we recognize it, so there is no highlighting that there's something wrong with it. Let's say, for example, that I want to make it even more complicated. Let's say that level up method returns an option of superhero. And what's happening here is that we will return an option of the new level, the better level, or in case of Hulk, the weak level. But if someone who is not Hulk but has the level of Hulk and wants to level up even more, then we just that person, that hero will die from that. So now we have a new level, and we map it. And yeah, so that's still like by default we put the parentheses here. You need to remove it, then put colon, and then let's say that level hop, and yeah, and this goes like this. And here, if we Iron Man is an option. Yeah, Iron Man is an instance, but level up is an option. So we can take this from here, and for each, and let's say hero println hero should work. Okay. Yeah, one more thing in build SBT. This is something we are now working on. If your SBT has a Scala option no ident, we recognize it, but we still didn't integrate it in our settings. So what we do is just, if you have no ident, then the whole Scala indentation-based syntax support is get turned off, and now you can just and now let's just highlight. I don't know. Yeah, this only works on one more thing that needs to be changed. Editor, editor. Not this, but highlight. So color scheme. Okay. So this only works with the compiler-based highlighting. Yes. There's something wrong here. Indentation definition expected, case found. Yeah. So if we work with compiler-based highlighting, and we have this no ident in SBT, then even though Scala support for the indentation-based is turned on in the settings, it's still not working here. So what we just need to do is turn it off now, and again resync. One more thing, maybe. Let's just wait for it. Extracting part factor. How much time do I have? Oh, 10 minutes. Okay. One more way that can, okay, you can see is the indent guides. Those are those gray little lines here that show you exactly the alignment of what's where is the given block of code is ending, starting and ending. What you can, this is just one way of using the X-ray mode. X-ray mode is this like a way of seeing additional code, additional information about the code directly in the editor. Here, when I turn it on, I can also see where the apply methods are used and what are the inferred types and so on. You can go to configure to settings, languages and frameworks, Scala X-ray mode, and just choose what information will be put in the code if you turn it on. One of them is indent guides here, and that means that you can just see the code without being like bombarded with this additional information. And the way you can turn it off is just turn it on is just using command. In my case, I click it twice and hold it, and then I see indent guides and those additional information. When I release it, it just disappears. There's also a way to turn it on completely permanently. It's called inline hints. And there are not so many things that can be turned on permanently because we figured out that people usually don't like it too much. There are like too many things that can be displayed in your code, and then you go back to inline hints and turn them off, but then you at some point decide that you should have them again because they are useful for something and so on. So that was the reason to actually develop the X-ray mode, where you can do exactly the same thing but quicker and easily. But sometimes some of those inline hints are actually useful to have them all the time. For example, if I have a list of chain of methods, then in inline hints I can choose to have the intermediate types of what's happening here also displayed. All right. One more thing I wanted to talk about is named tuples, which is right now in Scala 3.7 is standardized, and we have in Scala Plugin support for it from the very beginning, even before it was standardized. Let's create something that is called a hero tuple. This will be type hero tuple. And this will be basically like that case class superhero, but it will be instead a named tuple, so no additional allocation and less bytecode and so on. And let's say here in the main method, we will create Bob. Let's say he is strong, we don't know yet. And then Bucky. And then Yelena, but Yelena will be like not instead, because this is just a type alias. This is exactly the same thing as in all other type aliases. So in fact, we can use named tuples just directly. Only it's more verbose then. And let's say we have a list of heroes that is the sequence of those three. I should probably go back to language and Scala editor and go back to built-in here. Okay, so if I now infer this type, then yeah, the type alias is gone from the inferring, but anyway, Scala plugin tells me that this is okay. We have like Bob, Bucky and Yelena, and all three of them are the same type, and we can have a sequence of that type. If I, for example, now go here and say for that one more, there should be one more field in that named tuple, let's say hair color, blonde, then what you can see now is that, yeah, Scala plugin tries its best, but what it does is actually trying to find like a type that is that still covers all the cases, but is also the most strict of all. It's not any. It tries to not be any, to have actually something in it. Again, something we are still working on. On the other hand, if I now do like explicitly write here sec of hero tuple, then this will show me that there is a problem. Now, this sequence of those three don't really fit to the type sequence of hero tuple. So that's good. That's something that can be useful. Yeah, let's remove this again. So what's more with named tuples? We can, for example, have like a method register that will, it doesn't matter what it does, it's just like a method that takes the hero as a parameter, and now I can register Bob, and that will work. Maybe I shouldn't have, let's do it again, hair color, string, and blonde. I know I don't have that much time, but now if I try to register Jelena, then yeah, again, Scala plugin will tell me that this is not the name tuple that should come here. So this is like, we can see that even though tuple doesn't really is a case class, it still has some properties that can be checked, and we can see on this level if the tuple we're getting and we're giving is of the right type. So yeah, let's do this. Maybe let's simply remove Jelena from here. Okay, let's not. From here. And one more thing is the new pattern matching feature that we have thanks to named tuples. And again, Scala plugin has a support for it again already. If we have Jelena and now match, and now let's just okay, let's do it like this. And of course, hair color is not a thing. But this is the old way. We can case for we can match for name and level. If we don't need one, then we can say, for example, maybe not, it's not Bob. Let's say it, okay. Let's do it like Bob here, and that is Bob, actually. But what we can do now as well is this. So this was not possible before introduction of named tuples. That's because here we have like a pattern matching against one of the fields in a named tuple, and this works not only for named tuples but also for this little guy. So what we need here is superhero, a superhero with my small hand. Yeah. So all three together with this one is a valid Scala code now. And that's because the unapply for, synthetic unapply for case classes was written, and what we have now is something that looks like def unapply that is, how do I write it? Hero of superhero. Yes, and this is now a named tuple. So we have Yep. And this is done under the hood, so I don't have to do anything. But anyway, like we have this for free. Okay. Yeah, 2 minutes. I wanted also to tell you about something about transparent inline, but this is an experimental feature. If you want to try it out, you can, but this is still like very early in our support for transparent inline. You have to change to error highlighting compiler, and you have to mark this checkbox here, use types reported by the Scala compiler, which is like, again, experimental. And what we do now is we have this like add type annotation string false. Yeah, this is false because we don't say, we don't just, like we already, Scala plugin can already tell you that this is even more strict than just Boolean. It's always, if it's a Boolean, it's always false. I think that's it. Any questions?
Yes, I have a question. In the Scala, can I put like a Java code, for example, in the same file and compile?
Once more?
Can I place like this part of Java code here, for example? If I have like a checked tested code and I would like to use in Scala, can I paste and compile?
So you need to create a separate separate folder, like SSE main. I have one Java. For Java and Scala, but it is possible.
So the rule is just separately.
Yes.
What is compiler highlighting? Should we turn it on or off?
So compiler highlighting.
What do we do with it?
Compiler highlighting is like an alternative version of how a Scala plugin can learn about errors and warnings from the compiler, so similar to how VS Code does it. But because we, as in the built-in highlighting, which is more powerful, probably a bit also faster, but this is something that we need to work on. So new features in Scala often don't have support from built-in, but they already have support from the compiler, and hopefully we can use that information faster than in case of built-in. So we would like you to use built-in unless you really. Yes.
In general, is it better, do you think, sometimes to switch to metals? Probably they support newest Scala version on an ongoing basis, I think the support, or like how would you compare this IntelliJ plus Scala plugin versus metals plus an IDE?
Well, if you are, well, that's really a question to you as a team member. I would rather say that in a team of software engineers, it's better if everyone uses the same IDE. If you choose VS Code with metals, then it's better if everyone uses that. But if you use IntelliJ IDEA, then yeah, then it's better if everyone uses that as well, because that helps with transfer of knowledge and just going to someone and helping them on their computer. Which is better is really not really, it depends on the person. Yes.
As a bit of context, I do use this tool daily. So I'm curious, do you have a public roadmap for?
Just let me
maybe what's the biggest thing you're cooking?
Yeah, just a moment. I had it somewhere here, so it's better if I don't make any mistake.
Yeah, that's true. I'm just curious, what is the main direction that you are trying to take it?
Okay, so we're working on more like the newer or not yet well support things in Scala 3, like opaque types and intersection and union types. And also we already started to support using, like the new support for using and for context bounds, but there are a few things that needs to be still done there. There are many smaller fixes, something on the edge, like we support 90% of a feature, but we have still 10% left. In SBT, we are working on this new module layout that you can have different compiler options for production and different for tests. And that is also supported in the configuration of the project in IntelliJ. And also a lot of work goes to integration with AI Assistant and with Juni. So especially with Juni right now. Yep.
Thank you.
Anything else? If not, then yeah, please have some sandwich and some merchandise.
Yeah, we'll be back in like 45 minutes maybe.
Yeah.
Enjoy.
Okay, hello everyone. So my name is Haoyi, and this presentation is about better Scala builds with the mill build tool. So the motivation for this talk is that the complexity of Scala build tools like SBT has always been a pain point for people using Scala. It was a pain point when I tried to first learn Scala like 15 years ago, and it still seems like a pain point today. So this talk will explore like what are the problems with SBT and what are the kind of fundamental underlying problems underlying the things that we encounter day to day. And we'll look at Mill, which is one of my open source projects, and see how it tries to avoid or work around these problems so that you can get a much better experience than you may be used to using a traditional JVM build tool, whether SBT or even Maven or Gradle. So about myself, I've done a lot of open source Scala work. Who here uses any of these libraries? So many of you touched them at some point, probably not all of them, but some. My professional specialty is developer tools, so things like CI systems, dev environments, testing infrastructure, integration testing, and so on. I'm the author of the book Hands-on Scala Programming. So this talk will have 4 sections. We look at like, can Scala builds be easier than they are today? Like, is there a reason to believe that there's room to improve, or is it actually maxed out and as good as it's going to get given the problem space? We look at Mill, which is one of my open source projects. It's a build tool that tries to provide an alternative to SBT. We'll see what it is. We'll see why it's interesting, like what does it provide SBT does not provide, and what are these key ideas that allow Mill to kind of make progress where other build tools have not been able to over the last many years. So first, can Scala builds be easier? I think the basic problem with SBT is that it's too hard to use. Like, it's actually very performant, especially compared to Maven or Gradle, if used correctly. It actually is very flexible and extensible if used correctly. And the problem is that it's very hard to use it correctly, so you often will end up with an SBT build that, while in theory could do everything you want very quickly, in practice doesn't quite do what you want and is kind of slow and clunky to use. And although the Scala CLI nowadays works great for smaller projects, it doesn't really work for many professional code bases where you have like 100 modules or 50 modules in many integration test suites and other miscellaneous customizations. So just to dive into some of the details, like even just running SBT has a whole doc page of how to run it correctly. So most command line tools, you just say foo bar at the command line, it does what you want. SBT, you need to make sure you open the shell, you put stuff in the shell, and if you don't do this, it'll still work, but it'll work a lot slower. And you might not notice until you've wasted 5, 10, 20 minutes of your time waiting for it to compile things. Parallelizing tests, I thought, was surprisingly difficult. It took me 2 hours to try and get my test parallelized in one project recently, and I had to ask for help before I could get it working.
So you have like all these different flags. Parallel execution test works, except if you have fork, then you need test fork parallel, but you also need to set concurrency restrictions, but not the normal concurrency restrictions, but you need the test fork group concurrency restrictions. And eventually you can figure this out. Eventually I managed to get help to figure it out. But it's a lot trickier than you'd expect, given that you just want to parallelize things, right? You have 10 cores on your laptop or 15 cores on your laptop nowadays. Of course you want to use those to speed up your developer workflows. The IDE support in SBT is not as great as you would like, and I can show you this live. So over here, I have the Gatling code base. So Gatling is an open source JVM load testing framework built using Scala, and it's built it's like a big SBT project with many sub-modules. I can show it to you here. So you see that there is IDE support in SBT. You can jump to some things, like I can jump to like this. But often the IDE support doesn't really tell you anything interesting. In this case, I haven't set up the sources, so the code is decompiled. Some things you jump to get more useful information, but many things you just end up with these stubs. And even if you do set up the sources, all it'll tell you is a bit of documentation saying these are library dependencies. It doesn't actually tell you what you want to know. So like, why is that, right? Like, well, it turns out that these are really just kind of a proxy for a global mutable variable. So anyone in your SBT code, whether any plugin or any of your build SBT files on SBT itself, can set these global mutable variables. And just because you wrap it in this setting key data type doesn't make it any less global or any less mutable. So IDEs are very poor at managing global mutable variables. Humans are also very poor at managing global mutable variables. And that's why people don't use global mutable variables commonly in your application code. Like if you do, you'll find you just get just as poor experience exploring them in your IDE. And that's why I build tools like SBT, but also others like Gradle or Maven don't have a good IDE experience, because IDEs are good at methods, they're good at classes, they're good at inheritance hierarchies. They're not good at global mutable variables that these build tools are most often built upon. Like here we can see one in SBT. So if you already know what this does, it doesn't matter, but when something's misbehaving, if you're using a plugin that's not well documented, if you have an internal plugin that is not documented at all, if two plugins don't work well together, you're trying to figure out why, that's when having an IDE work in your code is very important. And unlike application code in Scala, Java, Kotlin, SBT code and Gradle, Maven code, you don't get IDE help really at all. So that's the IDE support angle where SBT maybe has a lot of room to improve. The last angle is extensibility. The first point I want to make here is that SBT really needs a lot of plugins. So SBT has a lot of plugins, which is good, but SBT needs a lot of plugins, which is not so good. So this is a list that Gatling needs. Even for simple things like running JUnit tests for JUnit 5, the most common test framework in the whole world in Java, it needs a plugin. Trying to do auto-formatting or whatever also needs a plugin. And so you end up needing to do this like tour of the open source ecosystem before you even can start working on your project. Like, of course, you want all these things, but you need to find the right version, make sure the plugin is maintained. These are maintained by like 15 different people, so you need to make sure each of those are legitimate people and not some like foreign hacker trying to masquerade as a legitimate person. And you end up copy-pasting these plugins from project to project because you don't really understand what they're doing or what version is correct, because it's not really something you want to care about. You just want to do the thing to your code. And beyond plugins, you often need to extend your code, your build kind of yourself. You can't always find a plugin that does what you want, and the plugins that does what you want may be half maintained, unmaintained, or generally not suitable for use in your project. So for this strawman example, I'm going to say I want to count the lines of code in a project and save it to a line count txt file to use at runtime. So this is arbitrary and contrived, but it's representative of the many arbitrary things you do in real projects, right? Like you want to have a custom linter, you have a custom deployment artifact, you have custom bill of materials to publish for security scanning, and all sorts of things like that that often differ from project to project, and you won't find the perfect plugin online just to drop in and make it work. So in SBT, this is not impossible. Here's an example implementation, but it's a lot harder than you expect. Like the logic on the top left should be a 30-second project for students that gets with 0% failure rate. Like it's so simple. You should be able to just walk the files, count the lines, and dump it to a file. But a student will not be able to get this working without a lot of fiddling, Googling, ChatGPT nowadays, or Gemini, or Perplexity. And when you look at why, the actual build logic I want to implement really is that simple. The build logic is like 2 lines of code and 1 line of documentation. But it's all the other stuff, like the wiring to make your build logic fit into SBT, that people won't know how to do. Like people know how to read lines, get the size and sum them up. People don't know whether you should use task key or task dynamic or other things like that. And Google and ChatGPT and docs often aren't as helpful as you'd like either. So this is like the baseline, right? Like this should be 30 seconds. Simple in SBT is a lot harder, and there's much more. Any non-trivial customization SBT will be harder still, and that's why people often try to avoid customizing their build tool whenever they can avoid it, even when they need to do something in their build. So that's the kind of long and short of what the problems with SBT are. Like in theory, you can do all the things you want, but it's a lot more difficult than you'd expect. And it's worth looking at maybe why is this the case. So build tools actually need to do a lot of things that people take for granted, like who depends on what needs to run in what order, what can be parallelized, what's a CLI syntax, how are things written to disk or cached. And this is separate from any customizations you want to do, like reading the lines of code and writing it to a file. And it's separate from any application logic, which is what you actually want to care about when you're developing a project. So if you imagine that you want to define an API to kind of expose all these concerns to users, it'll be quite a complicated API. And that's why build tools tend to be pretty complicated. Like build tools need to do all these things. If they do anything that is not done, you'll immediately notice. Your thing is not parallel, you'll notice. Things don't get cached, you notice. You can't customize a build tool, you immediately notice. So you take it for granted, but you really need all these things. And this makes build tools really hard to make simple, because what build tools do, this kind of big complex list of things, is not simple. So that's the can Scala builds be made easier point. Like it's kind of maybe it can be made easier, but it's not trivial to do. Next, let's look at Mill, which is a build tool that's an open source project of mine. So Mill is an open source JVM build tool. It's been around for coming on 8 years now. It started late 2017, originally just for Scala, now also targets Java, Kotlin, and other languages. And it's used quite broadly, not as much as SBT, but Corsair, which you all use to resolve dependencies in SBT, is built using Mill. Scala CLI is built using Mill. Chisel, the hardware design part of Scala is all in Mill, as is all of the commonly Haoyi projects you saw earlier. So if you guys use uPickle, OSLib, it's all built using Mill and has been built using Mill for 5-6 years now. A basic Mill build looks like this. So you'll see that it looks like Scala. You have a package, you have imports, you have object extends a class, you have methods, you have some dependency declarations, a nested test suite object, and its own IV dependencies and test framework. So you can foo.compile, foo.run, foo.test, foo.show-assembly, run the assembly later, so far, all standard build tool things. So here's a more involved example I can show you live. This is a HTTP4S server. Let me pull that up. Anyone here use HTTP4S in Scala? Some of you. So these are the popular web servers. Let me just go back to this project. So I can do mil -- watch. Can you see this? Is this big enough? Yes, OK. -- watch, run background. I think I can open up. It says it's going to watch at localhost 8084. So here's my HTTP4S like to-do MVC app. You see, there's a lot more dependencies than the hello world we saw earlier, but it's things you expect, like the server, the Scala tags, HTML rendering integration, the test framework, and HTTP4S test client and test utils. I can make changes to this, and it gets picked up automatically. So let's say I want to change to-dos to like to-dos hello. As changes, it gets picked up, recompiles, restarts, and now we have it. So so far, nothing special, just showing you some of this stuff that you can do with Mill. People often ask, what does Mill support? And apart from things like HTTP4S and web frameworks and other things, it supports most of what you'd expect in the open source side of the Scala ecosystem. So it won't support all the any proprietary plugins you have in SBT or Maven or Gradle. It won't support some of the paid plugins you can find on the internet and some of the more obscure ones. But at least most of the common ones like Scala Fix, Scala Format, S Coverage, all the different test suites, those are supported out of the box. Things like publishing to Maven Central using Sonatype Central or whatever, those are all also supported out of the box without needing any plugins. So it's quite convenient. So this is a short tour of all the things that Mill does that other build tools also do. So that's not very interesting. Like you can just use the other build tool that already does these things. So what's interesting about Mill then? I think what's interesting about mill is that it just does all these things easier and harder to screw up than existing build tools like SVT. So things like performance-wise, as a benchmark, we took the Gatling code base and ported it from SVT to mill just as a proof of concept. So the real code base uses SVT, but we just wanted to try it out to have a real comparison. It's quite a big project, 80K lines of Scala. And what you realize using SVT and mill is that SVT really has two performance profiles, whether you use it correctly or not. It's very easy to use it incorrectly, and then it becomes slow, but it's easy to do that. It's a bit more troublesome to use it correctly, but then it becomes much faster because it keeps the JVM warm in memory. So mill basically does a hot SVT kind of manual work for you in the background. So rather than you running reload, rather than you restarting a server and running Control-C and restarting a server when necessary, mill will automatically start the server in the background, restart it when necessary, reload the config. So with mill, you basically get the same performance as hot SVT, like not actually that much faster, it's about the same. But the command line ease of use is the same as cold SVT, and like any other command line tool, you just say mill something, don't need to worry about managing a shell and managing reloads and updates and all that stuff. So compilation is not everything. Mill has a bunch of other nice features to speed up performance. Things like selective test execution. So you can ask mill to take a snapshot on the main branch, take another snapshot on the pull request branch, and ask what test suites are affected by this pull request change in code. You can ask what test suites are affected, how they are affected. They'll print out this nice JSON tree showing you how this source folder affects this, affects the test suite. And you can ask it to run only those tests that change. So this is very handy in a large code base where you're often not actually touching the entire code base, you're touching some small subset, and running all the other tests is just a complete waste of time and money. Incremental assemblies are quite nice. So all build tools take a long time to make large assembly jars. So in this case, a 200 megabyte assembly jar for Spark Submit takes about 20 seconds, and you need to spend that time. But assembly jars can be updated very quickly because they're just zips, and it's very easy to take things out of zips and put new things in zips when your class files and other things change. So that's what mill does. So the second time you create the assembly second time you update the assembly after adding a new Scala file in the project, it takes 1 second because it doesn't recreate the jar from scratch. It takes the old jar, copies it, and just surgically puts in the new file and takes out any files that should not be there anymore, which is very fast in the zip file. So I don't know why the other build tools don't do it, but other build tools, you always have to recreate it from scratch. It always takes very long for things like Spark Submit. And in mill, it's just basically instant. You can iterate on an assembly jar. It's easy to iterate on any other piece of code within less than a second. The last thing that's worth looking at is the mill Chrome profile. So every command in mill spits out a profile like this that any of you can load on your laptop without any installation or downloading or registration. Let me show this to you. So let's say I go to our checkout of the Gatling code base and run mill clean and mill _compile. So _compile is like a wildcard compile everything. You can see it's doing a bunch of things in parallel, like SVT has a nice terminal UI to show you what it's doing. Let me open it in the IDE. So while this is running, even before it finishes, it spits out this mill Chrome profile.json file. So this is a standard format that all Chrome browsers support to visualize multi-threaded performance profiles. And most of you probably don't know, but every Chrome browser comes with this Chrome tracing user interface. Has anyone used this? No? So if you want to profile and understand the performance of something like a parallel workflow, you just dump the timestamps into this JSON. It's a standard format that Chrome documents on its website, and can load it into Chrome to see where my time is going. So earlier you may have you saw we were taking several tens of seconds to compile Gatling, and you may wonder like why is it taking so long? This is a very common question developers ask of their build tool. And all build tools have some way of answering a question, but mill makes it just really easy to see that, okay, we're bottlenecked on core compile here, we are bottlenecked on HTTP compile here. At first, we are making good use of all our cores, but later on, we seem to be getting more and more throttled based on the available parallelism in the build. And maybe this can give you ideas of how you can improve this workflow. Maybe you can break up core compile, you can break up HTTP test compile, and so on. And even when the thing hadn't finished yet, we could already run this to see where our time is going. So even if your build is stuck, if your build is hung, you can see where's the time going in your build, so you can take action of it. So even if you know nothing about mill or you know nothing about Gatling code base, you can already get a good intuition for why it's taking this long to compile and how you can improve. So this is very handy in any real project where you often find yourself waiting. So that's the idea of easy performance. So none of this is impossible using things like SVT. You can juggle the shell yourself. You can find some plugin that will give you a profile and tell you how much time your tasks are taking. But in Mill, it's just so easy to get the JSON file, dump into a Chrome browser you already have on your laptop, and see where's the time going so you can speed it up. The next thing we're going to look at is the IDE support angle. So to do this, we're going to take our Gatling code base again, which we use as a as a comparison, and we'll compare the Gatling for Mill on the Mill build on the right with the Gatling for the SVT build, which is on the left. So just picking an arbitrary submodule, right? Like there's Gatling core here, and here there's also a Gatling core here. So this on the left is a Gatling core config in SVT for the core module. The right is in Mill. The first thing you realize is that Mill is actually a lot more verbose than SVT. We're not competing on number of lines of code here. And it actually contains all the same information. It's spelled a bit differently. Like instead of lazy val core, you have object Gatling core. Instead of Gatling module as a function, you have Gatling module as a class. Instead of depends on, you have module depth. But basically, it's the same information, just spelled differently using the Mill kind of API. Where things are different is that where SVT, you hit these stubs, you basically hit the wall if you try to explore the build using IDE, and you can't figure out what the build is doing unless you already knew before, you memorized it from a book or from Google earlier on. In Mill, all of these, instead of being global variables, they are method definitions. And the one thing that IDEs are good at is exploring method definitions and method calls. So for example, if I look at fork args here, you can see that this overrides fork args from somewhere else. IntelliJ knows that. IntelliJ can show you that fork args gets called here in runner. That runner gets called here in run background and in run fork task. Run fork task gets called in run. So rather than just hitting an opaque wall where we tweak this key and we can't see what happens later, in Mill, you can really explore your build code base just as easy as you can any application code base. You can jump to definition, you can find overrides, you can go downstream to find usages, and you can go upstream as well. So over here, we have final main class. Let's say I don't know what that does. Maybe the documentation is out of date, or maybe something's misbehaving and documentation is wrong. I can just jump to it. Here, there's no documentation, which is bad, but I have implementation. So I can see that, OK, it depends on final main class opt. What's that? I can jump to that. Again, no documentation, but I can see the implementation. And I can see that first it tried calling main class, which is any explicitly configured main class. If there is one, it uses that. If there's none, it calls all local main classes. What's that? I can jump to that and see that, OK, it uses this class graph project, which is another open source project, to scan your class files looking for a main class with the appropriate main method. So none of this really matters if your build is always working and doing what you want. But when your build isn't doing what you want, or trying to make your build doing something different, being able to explore your build in the IDE the same way you explore any application code really makes it a lot more comfortable and less scary. Like in SVT, you're kind of tweaking these magic values and hoping it propagates somewhere to do the right thing somehow. You can kind of explore it in a command line using SVT inspect. But with Mill, you can really just use the same IDE experience that you use day to day, jump to definition, find usages, get back out, find overrides. You don't know what this method class is, it's just a normal trait. It extends another trait putting with additional definitions. You don't know what the upstream trait is, you jump to that. You can see that, OK, this is where the sources are defined. Makes it very easy to explore your build and really understand it. So your build no longer becomes this scary, opaque thing. It just becomes like any other application code, except it runs in parallel and it's cached automatically on disk as you evaluate it. So that's the IDE support angle, where although they both nominally have IDE support, they're both nominally Scala programs. SVT is kind of a weird Scala using lots of global variables that IntelliJ can't work with, and neither can most junior engineers. And Mill uses method calls and objects and classes, which are things that IntelliJ is very good at working with, and it's very good at navigating up and down these class hierarchies and up and down these method call graphs. So that's the IDE support angle, where despite being like a brand new project that's maybe used much less than SVT, has much better IDE support already. The next thing we're going to look at here is extensibility. So the first thing to mention is Mill has a lot more stuff built in than SVT does. So it does have plugins, But of these plugins, we saw that the Gatling code base needed. Only the ScalaFix plugin is an external plugin in Mill, managed by Joanne Goyer, who works at Netflix. The others, like things like packaging assembly jars, native images, JMH, JUnit 5 Jupyter, all those are built in, which really helps you get started quickly rather than spending time fiddling with plugin versions and dealing with conflicts. And when the time comes that you do need to extend code beyond what is available built-in or available with third-party plugins like Mill ScalaFix we saw earlier, Mill is interesting, and you can just write code to do what you want very easily. And we'll see what that means. So let me show you this live. So on the right is the Mill build for like a minimal Scala module. And let's make this bigger. So I can run Mill like foo.compile. You can see it says compiled this thing and did not and exited. And there's nothing much interesting here. So Mill has defaults like SVT. If you just use the default everything, then you just get all the defaults inherited from Scala module, just like any other inheritance. But let's say we wanted to do what we asked about earlier, which is count the lines of code in this project and write it to a file. So how do you do this in Mill? Well, in Mill, custom tasks and any other build workflows like build pipelines are just methods that call other methods. So in Mill, you can just say def line count is a task. And inside this task body, you call other methods, which are also tasks. For example, I can say foo dot. Maybe I want one of the source tasks. You're not sure which one. You can see we get good IDE support in IntelliJ. VS Code also works. You can say foo dot all source files. And you can transform this like I want to get the file path. I want to use OS read lines of the file path, get the size. So this is a standard OS lib library that's part of the Scala toolkit. Everything behaves the same as you use any other code base. And I sum them up. So this is all you need to do to define a custom task in Mill. You have Scala doc if you want, it's optional. You have a def method equals a task block. And within task block, you call other methods. And you transform and do whatever you want with those values. So here, now that's all I need to do to say Mill show foo.line count. Now I need to recompile because I changed it. Scala compile is a bit slow the first time, but it'll warm up as you use it. See, the second time it becomes very fast. I can do Mill inspect foo.line count. You can see that we capture things like the Scala doc automatically for you. So IntelliJ knows how to read Scala doc in comments. IntelliJ doesn't know how to read Scala SBT docs in strings. So rather than putting things in strings, we let you put in Scala doc and we'll manually grab it out to put it in the compile, to display it at runtime. We also capture things like the file name, line number for you automatically. On line 8, for debugging purposes, capture the inputs for you automatically. You call this method so we know that you depend on it. You don't need to separately go and declare it depends on or something. And so that's all you need to declare a task in Mill. It's really just a method that returns a value. You see, we're not reading or writing to files or anything to cache anything. It's just a pure method. So here we have a custom task, but we haven't wired it up into resources like we saw earlier. So in Mill, resources are just a task, and tasks are just methods like any other task. So to customize resources, we need to override it. And in Mill, this is done using normal Scala overrides. So you override def, you get good ID support in IntelliJ. You don't know which one to override, you can ask IntelliJ which one they do and what the Scala doc is, what they do. In this case, I want this super.resources. And I want to say os.write to task.desk /line count.txt. And I'm going to say line count as a string. And I'm going to append to my resource path. Resource paths and class paths can have multiple entries. So I'm going to append to my resource path a path reference to this task.dest folder. So it's worth mentioning, like, what is task.dest? So if I show you on disk and I say mill show foo.resources, you'll see that apart from the original foo resources, which I kept because I'm keeping the super here, despite overriding it, I also have in the out folder, which is output generated files for mill, we have out/foo/resources.dest. So this is a task.dest folder, and the purpose of this folder is to help manage the files on disk. So why is that important? Because the file system is basically the world's biggest global mutable variable, where anyone can read to anywhere, from anywhere, anyone can write to anywhere. You can have multiple tasks racing to delete things or stomping over each other's files, or you don't know who's writing to where and whether what you can delete safely, otherwise, or what you can't delete because some other task is depending on it. So without some kind of management, the file system is just a huge mess, just like any other big global mutable variable. So with mil, we impose two constraints. One is that every task should only write to a folder that's given to it based on the task name. So foo.resources gets out/foo/resources.dest. So from a global mutable variable file system, it becomes like a local mutable file system. And then we have another constraint, which is you don't mangle the file system returned by upstream tasks. So right now, it's just a convention. The next mil version will be enforced by a linter or checker, which means that from a global mutable file system, become a local mutable file system, to become a local immutable file system, and suddenly it's not so scary anymore. You can write stuff to task.desc. You never need to worry about collisions. You never need to worry about where things are written. You never need to worry about what can I delete safely, because every task, you always know where its files live. You want to use them, they're always in the same place. You want to delete them, they're always in the same place. They'll never collide, they'll never have race conditions, and so on. So that's what this task.desc is here. So just to sum up, we define a new line count task that calls all source files. It reads all the lines, adds them up, sums them up. We overrode resources, and we have made it a task where we write a line count txt file to the destination folder and append to the existing resource path, because we don't want to throw away the existing resource folder. We append a reference to the new task destination folder. So now we can see that in out/foo/resources.dest, there is now a line count txt file, and you can cat the file to see its value, and we can do mil-foo.run to see that the small application code, this is a small snippet of Java code in this project, is able to read this file at runtime and display the number. So this is a bit small. Let's go to a slightly bigger example. Let's say instead of just writing a line text file, the line as a text file, I want to write it as a HTML file. So mil doesn't come built in with any HTML templating library. You can't do like import Scala tags.text or all here, and it'll just fail because it's not a web framework. Why should they have HTML templating library? But what mil can do is you can just import things on the fly using this import IV syntax. So you can say import commonly Haoyi Scala tags, let's say 0.12.0:0.12.0. And now when you run it, you'll see that it no longer is a compile error. I can ask IntelliJ to reload it. It'll take a moment, but I already have it cached on disk, downloaded earlier, so you can see now it's available in my libraries, external libraries tab in IntelliJ. VS Code works as well. You can navigate Scala tags in your IDE now. And I can start using it with all my nice IDE support. So I can say HTML snippet is a task, and I'm going to want a div with a h1 line count and a paragraph, which is a line count, as a string, and render it to a string. Now I can say mil show foo.html snippet. You can see that I have the snippet kind of rendered at build time using the line count that's also computed at build time. I can open the cache file on disk to see where it's cached. So the foo HTML snippet task gets a foo out/foo/html snippet.json file. You can see that apart from the value that we cached, which was a string, we also cache some metadata to let mil know how to invalidate things when the hashes change. And now, if instead of writing the line count here, I write the HTML snippet, I'm able to have it get picked up at runtime by my runtime code, a pre-rendered at build time HTML page using a third-party library from Maven Central that mil doesn't know about, and I can just use it directly in my build. So what's interesting here is that there is no mil line count plugin, there is no mil exec plugin, there's no mil HTML templating Scala tags plugin, and with mil you don't need to. With mil you just take the library that does the thing you want, whether it's a code generator, whether it's a linter, whether it's a auto formatter, whether it's a packaging binary, just take it, download it from Maven Central or wherever else these binaries come from, and you can use them directly without going through a plugin. So often the plugins are the least well-maintained part of the ecosystem, like you have SBT, which is well-maintained, you have maybe some other framework that's well-maintained, but the SBTX plugin integration is often the worst maintained part of the ecosystem that maybe no one really touches and no one wants to work on. So with Mill, this lets you bypass all that and just use the X directly, whether X is Scala tags, whether X is something else. Just pull it in, write whatever code is necessary, and you get all the other things like caching and parallelism and validation all for free. So that's the, this is a demo we saw live. But that's the extensibility angle, where with Mill, you can just do things in your build with the full ID support, full library support, full Scala language, and it ends up being really easy to configure versus something like SBT or even Gradle or Maven, where you end up having to kind of contort your configuration in order to achieve the thing you want. So I think that's why Mill is interesting, right? That it's easier to get good performance. It's easier to understand in your IDE. You can navigate the build graph and explore it. It's easier to extend. You can just write the code to do what you want. And if all the code you want to be, if you have code that you want to reuse, turn the object into a class and push it to Maven Central, and other people can use it. So it's very easy to configure your own builds. Also very easy to write plugins for other people to use. So that's why Mill is interesting, but why can't SBT do this? Why can't Gradle or Maven do this? I think that's where this last section comes in, these key ideas. So there are three key ideas in Mill: pure functional build graphs, object-oriented builds, and direct style instead of staged like Scala DSLs. So first, let's talk about pure functional build graphs. Basically, every build step, like not every, but 99% of them, have the format of do something to inputs to make outputs. There are some exceptions, like auto-formatting, you mangle the inputs. There's some other code that reaches back and touches the inputs. But generally, it goes from input to output, input to output, input to output, without any backwards data flow. In Mill, this is spelled like def output equals task, do thing input 1, input 2. But it's the same meaning, just in the Scala syntax with this task wrapper. So you look at all the things that a build tool does. Resolve dependencies to make dependency jars. Code gen on IDL to make source files. Compile source files and dependency jars to make class files. Test class files with dependency jars to make test results. Always follows this same pattern over and over. So there are two ways you can express this. One is I have a functional way where I have a task that reads the upstream task and returns the value. Whoops, where did it go? Here, I have a task that, like line count, that reads upstream task and does some transformation and returns its value, but is pure in quotes. Not quite pure because of the file system, but as I mentioned earlier, because of the destination folder, we can effectively treat the file system as an immutable data structure here. Or you have the imperative version that just reads things off disk and writes things to disk kind of arbitrarily. This is the more common thing that most build tools do. SBT custom tasks where write files, or Gradle or Maven tasks, they often just write things to disk somewhere, and it's not really controlled by the tool. It's up to the user to put wherever they want. So both of these have the same basic logic, but what is different is that one is functional, one's imperative. For the imperative code, I can't really parallelize it because I don't know who's reading from when, who's writing from where. It's very hard to figure out. I can't easily cache it because I don't know whether there's some side effects that if I cache it, the side effect won't happen and something will go wrong. I can't easily invalidate it because I don't know where the outputs are, because it's written somewhere in some code, and I can't look into the Scala code to pull out to figure out where the outputs are being written, at least not easily. So although it's the same kind of semantic logic, the functional code turns out to be a lot easier for the build tool to work with, because you are not reading and writing to random places on disk as a global mutable file system. You are only reading from things that you are given and writing as a return value that Mill will handle for you, or writing to your destination folder. Mill can very safely parallelize, cache, schedule, invalidate all your tasks without you having to do anything at all. Like, there's no cache logic here. You just write the pure code and Mill caches it for you because Mill can safely do so. So pure functional programming is also what makes jump to definition useful, because global variables like unmanaged source directories, which are wrapped in a setting key, are still global variables. So when you jump to a global variable, you don't know who's setting it, you don't know who's reading from it, because everyone is setting it all over the place, and everyone's reading all over the place, and who's setting it and who's reading the value that I care about, you don't know. Whereas with Mill, because these are just methods and they are pure methods, when I jump to all source files, I actually get how it's computed, what's the value that I get when I call it. And any of these things inside, like all sources, I can jump to it. sources, I can jump to it. Because these are all pure functions, so all these jump to definitions actually bring you to the computation of the value you care about, rather than to this global mutable variable stub, which tells you nothing. So that's the idea of pure functional programs, build graphs, where every build is mostly pure functional build steps. And by treating them as pure functional build steps, IDE and the build tool is able to provide a much richer, much more automated experience than if you were allowed to just read and write arbitrarily to disk, like is common in traditional build tools. Next, let's look at object-oriented build definitions. So this is a kind of rehash of what we said earlier, but what build tools need to do is actually very complicated. So one of the things build tools need to do is they need to define, let the user define these templated customizable graph computations. And this is quite a mouthful, right? But when you look at it, for example, I have 3 modules here. Each module has sources, each module has compile, each module has class path. They depend on each other internally, but they also depend on each other across modules. And although they are very similar, they're not quite the same. Like foo.bar.classPath has no upstream class path, whereas foo.classPath depends on foo.bar.classPath. So they need to be templated because all the modules look very similar. They need to be customizable because they're not actually the same. They're similar, but there's always some difference. Needs to be a graph because we need some way to order and schedule and parallelize things. And we need to actually do the computation at each step. We're not just modeling a graph. We need to do the thing to make your build happen. So again, you imagine you define your own API to make a templated customizable build computation. It would be quite a complicated API. Like, just imagine, like, what does this look like? You define a class as templated customizable build graph computations exposed as a user-facing concept. And even if you don't need to do it because a plugin author did it, it's still a problem for the plugin authors. And that's why plugins in build tools often end up being flaky, slow, or they end up interacting poorly with other plugins. Because if the plugin author has trouble defining these templated customizable build graph computations, the plugin is probably going to have problems. And you as an end user will use a plugin which is problematic, slow, flaky, or poorly interacting with other plugins. So Mill needs to do this as well. But the interesting thing here is that you already know how to define templated customizable graph computations. It's called object-oriented programming, where you have a class that has multiple methods that call each other. These form a call graph. And you instantiate the class multiple times. You have separate little call graphs, one for each instance. And you want to customize it, you override the methods. Or have a subclass that overrides methods and instantiate the subclass multiple times. And the body of the method is the computation that each step does. So you all already have a kind of built-in idea of how to work with templated customizable graph computations from when you first learned Java 101 like 20 years ago in school. And we don't need to come up with our own API. We can just reuse the one you already know. So when you look at like object foo extends Java module, it's literally an object that extends a class or trait in Scala. You inherit all its methods. So methods call each other, like sources gets called by compile, gets called by class path, gets called by assembly. You already know how that works. This is slightly simplified. When you define your own method like line count that calls all source files, when you override resources and call super resources and call line count, you already know what this affects the call graph because this is exactly what it works like in any Java program or Kotlin program or even Python TypeScript programs. And even concepts like override and super, which are quite tricky concepts, because you've already learned them before, I don't need to teach you. Like if you have to learn a new thing that's as tricky as override and super, it may be troublesome, but you already learned override and super, you already know what this does. You already know how it keeps the super around, and the downstream methods called a new override implementation. And once we have this graph, we can do things like parallelize it, where the red and blue sections can run in parallel because they don't depend on each other. The green section needs to wait for both red and blue to finish before it starts. Mill knows that every one of these tasks methods has a name, like foo.lineCount, bar.compile, or quux.assembly. They all have names, so we can like qualified names. And so Mill is able to assign them all places on disk to cache their JSON file metadata, as well as any desk folders for any file outputs, since like compile outputs, assembly jars, and so on. And also the command line syntax of foo.lineCount, foo.compile, foo.assembly we saw earlier is exactly the same syntax you use in your code base. It's just your object-oriented foo.bar.quux kind of syntax. And lastly, Mill is able to do incremental invalidation. So if you touch a resource folder, which is now super resources because you overrode it, Mill just does a breadth first search, knows it needs to invalidate resources, invalidate foo.assembly. It knows that where foo.assembly's output is, so it knows where to delete it safely. It knows it can reuse the output of compile and line count because those are not dependent on the thing you touched. and also knows where to fetch those metadata and file data from, because those are all following the standard format. So MIL can do all this stuff for you because it limits you in what you can do yourself. Like, you are not allowed to read and write to random places on disk, but as a result, MIL can take your code, which is kind of pure functions, and schedule them and invalidate them and recompute them very, very automatically and safely. So if you look at this code here, the interesting thing here is that there's no code related to parallelism or caching or dependency tracking. We don't see any depends on calls like in Gradle. You don't see any ad hoc caches reading and writing to disk like you see in SBT sometimes. Some build tools, you have plugins that spawn threads and parallelize things themselves, or multi-process. Here, you basically write pure build logic doing exactly what you want to do in pretty concise Scala code. And all the caching and validation parallelism happens for you by the build tool. So that's object-oriented build definitions. So I think complements the pure functional build graphs very nicely. Like, pure functional build graphs are great, but you get things like you need to template your build graph. You need to customize your build graph. That's where things like overrides and classes and supers and stuff become very handy. The last thing we're going to look at is the direct style DSL instead of a staged DSL. So if you compare SBT and MIL, both of these are Scala, but the Scala on the left looks a lot more like the Scala you use day to day than the Scala on the right. You use objects, you use classes, you use Scala doc in comments, you use methods. You don't generally use lazy val task key things with strings documentation in your application code. You don't generally use like lists of arguments with colon equals in your application code. So although they're both Scala, SBT is much further from Scala than MIL is, and that's why IntelliJ has problems understanding it. So when you look at what SBT is, it's really two programs. One is the Scala side, things like Scala doc, there's none here, things like objects, there's none here. Methods, you see some method calls like settings and task key are method calls from Scala. Lazy vals, Scala lazy vals. Scala operators like colon equals or plus equals are just Scala methods, as you all know. So SBT, you evaluate stage 1 first, and IntelliJ can understand stage 1. IntelliJ can understand stage 1. But what's interesting about SBT is that so much of the logic is in stage 2. So colon equals is a Scala operator that has a method defined on the line count class or trait or whatever. And that tells you nothing about how line count was computed and where it is being used. Compile / resource generators slash is a method on the compile object. Resource generators gets passed that method, which is all fine and dandy, but tells you nothing about what the resource generators are and who's using them and what they were before I'm adding to them and all these other things. All that other stuff that you actually do care about in SBT is in this stage 2 up here. And that's why IntelliJ, as well as humans, have problems with SBT. Like, you learn programming, you learn Scala, you learn the stuff in the bottom right, and it gets you halfway there. And then the stuff in the top right, you know nothing about. Your IDE knows nothing about. IntelliJ knows nothing about the 4-dimensional scope hypermatrix. IntelliJ knows nothing about how settings lists interact and all that. IntelliJ knows overrides, but these are not overrides. These are something different. And so IntelliJ can't help you with the most important part of your SBT build. MIL, on the other hand, kind of lifts heaven and earth to squeeze everything into stage 1. And so things like, we take the Scala doc and use as comments and show it to at runtime. How do we do that? You can't get Scala doc at runtime. So we have a compiler plugin that will look at your Scala source file, parse all the comments out, and put it in Java annotations for you to use later on. So that's how we do that. Like the task computations, like dependency tracking, like line count, we call all source files. How do we know that line count depends on all source files? You can't normally look at what methods or method calls without running it, right? You can't just ask a method, hey, who do you call? Give me the list. So we have a macro that will pull this metadata out for you and store it again in some annotation or some metadata object for us to use at runtime. So the implementation of trying to squeeze all this into stage 1 gets quite hairy. But the user experience means that because you already understand methods and objects and classes and traits and Scala doc, and IntelliJ already understands methods and objects and classes and traits and Scala doc, both humans and IDEs are able to work with the MIL build much more easily than any SBT build because it looks like Scala, that looks like the Scala you use day to day and not like the weird Scala that IntelliJ makes you write, kind of that's different from what you use day to day. And if you come back to this laundry list of why a build tool is complicated, MIL also needs to do all these things, But because MIL uses functional programming, it's able to kind of answer many of these questions even before you even knew that there was a question. Like the method call graph tells you what method calls other methods, what method depends on other methods, so that's the graph you care about. The method call graph tells you what needs to run in what order. The way you define custom tasks is you define a method. You already know how to do all these things. So although I didn't teach you, you already know how to do these in MIL because that's what you do day to day in Scala. And the things that aren't covered by functional programming are often covered by object-oriented programming. Like the command line syntax for MIL is just your object-oriented, like object.methods syntax. The disk output paths are just object slash method name dot destination. Repetition is managed by classes or traits, and customization is done by overrides. And you already know how to do that, so you already know how to do this whole laundry list of things without learning a single new concept, because these are all just standard functional and object-oriented concepts. So those are key ideas behind MIL, which I think are very interesting. The pure functional build graphs, object-oriented build definitions, and this direct style DSL are things that most other build tools do not have. And that's why SVT, as well as others like Maven, Gradle, or Bazel, despite decades worth of investment, have not been able to get the ID support that MIL does with like one guy working on it for a few years. Have not been able to get the ease of extensibility that we've gotten because as like a small project. Because of these concepts, they make life so much easier for both the build tool, the build authors, as well as plugin authors, as well as the build tool maintainer, which is me and the other maintainers on the project. It's just so much easier because of these ideas. So this is the last slide. So can Scala builds be easier? Like we think it can, but it's not easy. And we think MIL is interesting because MIL is able to do these not easy things. It's much easier to get performance out of MIL. It's much easier to explore in your IDE. It's much easier to extend and customize. And the reason we can do this is because of these interesting ideas. It's not just academic. Like the pure functional builds, the object-oriented builds, and the direct style builds, these translate into concrete improvements in ID support, extensibility, and ease of getting good performance that other build tools really struggle with over the last few years and decades. So hopefully, if you're interested, you can try out MIL. The doc site is here. All the examples on the doc site are tested. So you can take any of these examples and download the zip file that you can run directly on your machine, unpack and run the MIL build to try it out. And there'll be instructions on the commands you can run. And they should all work because they're integration tested. And there's also some migration instructions for migrating to MIL from other build tools. Like we have some automated tooling, as well as some manual steps that you need to do, even if you use automated tooling. So that's the end of the talk, and I guess I can take questions if there are any. Thank you.
One of the biggest pain for me with the SBT is actually something more down to earth, dependency eviction, and like trying to find out what depends on what, and then correctly excluding on defining a specific version. So yeah, there's I think some plugin for IntelliJ for like creating some graphs, quite easy to understand. But then later with this build tool, I'm adding this ignore some dependencies, and it turns out it's in the wrong build stage. It's for test. Do this MIL have some tools to make it easier to find that this doesn't build because we have evicted dependency, and how to select precise version?
So MIL has this built in. I think it's called ID depth tree. So the ID depth tree for this is not so interesting. Let's go back to the HT4S example. I think this one is just ID depth tree without the full. Yeah, so this just shows you a tree of who depends on who with all the evictions. In this case, it's quite gnarly because there's a lot of duplication. HTTP4S, lots of things depend on the same upstreams. But generally, this tells you why things are getting evicted, and if you want to exclude something from a dependency, this tells you, given what you depend on directly, in this case, for example, the HTTP4S Ember server, what the dependency tree is that got you to the thing that you may want to exclude. So you can easily see, like, for example, if I don't know who is inheriting cat's kernel here, I can just search for cat's kernel, and then trace it up the dependency tree to see that I'm getting cat's kernel as part of HTTPS for Scala tags. Just following up this tree and ignore it from there. So there's some tools like this. but fundamentally uses the same dependency resolver as SVT, which is Corsair. So the underlying algorithm will all be the same. We just try and make it a bit easier on the surface. Yeah.
Okay. So like giving some, for example, for this cat to enforce some dependency, it would be automatically added to like all the like compile test stages and so on, or would it be difficult, for example, like right now to exclude some dependency or define a strict version, is this not that, in this mill build code?
There is, we call it the bill of materials. So there is support for defining a bill of materials that you use in multiple modules and enforces the same version as used in all of them.
Okay.
I don't have time to show it to you now,
Okay,
but it's
okay.
there on the docs. Yeah. Kind of follows what Maven does with dependency management, where you define a list of versions and later on you just define the depth without the version and pull in the version from your bill of materials.
Okay.
Yeah. Any other questions?
Yeah, actually 2 questions. First of all, like, if you look at the landscape of build tools in Scala right now, so maybe SBT, Mill, and Scala CLI is maybe the top 3.
Yeah.
So how would you compare them? Like, what's the use case for SBT, if there's any, from your point of view, and where are the other build tools like?
Sure.
Like, yeah.
So Scala CLI is very, very good for small projects. Once your project becomes a bit bigger, even not so big, you end up having like a large number of flags in the bash command line. And as you know, like configuring things with long lists of bash command line flags is not the ideal experience. You don't get autocomplete, it's easy to mistype, quoting and escaping is problematic. Put exclamation mark in there, everything screws up. So for just getting started, maybe for students just learning, it's great. But for any project that grows like 2 modules and a test suite, it's kind of out of scope for Scala CLI. SVT, I personally think is not really that necessary anymore. I was at Databricks before I left, and my open source projects as well. I have not touched SVT for 6 years now, basically. Like all open source projects use Mill. Databricks internally, we have some Mill, some Bazel, and yeah, it turns out that like calling Scala C and making zip files and renaming them to .jar is not rocket science. Like, there's nothing SVT does that's super magic that we really need the build to. Like, and Mill basically does all the things, and I think has at this point caught up in a lot of the ecosystem. So you want things like the Graal VM native image. I want Kotlin native support, or Scala JS support, Spark support. Mill has already kind of caught up to that. 5 years ago it hadn't, but now it has. So yeah, I think for Scala CLI, it's good for getting started. For Mill, it's good for anything after that. For SVT, if you're on legacy things that's not causing a problem, it's too painful to migrate, then fine. But you probably wouldn't make sense to start a new project on SVT. I think you've all had experience being confused by SVT for all the reasons I stated earlier. And for very large projects, let's say you have 1,000 developers working on a project, then maybe you want to look at Bazel or Pants or Buck, because they will provide tools necessary for such large projects. Yeah.
Okay, thank you. And my second question is about migration. So I think like in the past at least, I heard the biggest problem were like plugins. So is there like in a doc like a table that says like, okay, if you need functionality of SVT native packager, you should use this?
We don't have a plugin table, but we have index table. So most of the things that you care about should be somewhere here, like whether packager, Docker, Maven Central, test suites, all the linters, and so on. And we have a search thing here that usually pulls up things quite quickly. So for example, if you want jailing support for Scala, then you have it here. It links to the Java docs. Yeah, so there's a doc for like jailing, for example. I want Scala native WASM support for WebAssembly. Here it is for Scala WASM. So we don't have a plugin-to-plugin table, but if you know what you're trying to do, you either Google it or just use our search. You'll probably be able to find it, and you should have an integration tested example showing you how it works. Yeah.
Perfect, thank
Cool.
you.
In the back, there was a question. What's there?
Yes, I can go to the 3 screen.
Here? Oh, sorry.
Yeah, I would like to ask about the commands here. Interoperability. I would like to find out if let's say, the new version Java appears, how much modifications will be required in the settings?
To use a new version of Java?
Yes, for example.
Okay. Yeah, so let's look for that.
I noticed you already has put some remarks.
Yeah, so Mill does support kind of managed JVM versions like Gradle does. You can define a JVM object like this that uses a particular version of Java and use it in your other modules. That is for the modules that Mill builds with application code or test code. Mill also has support for upgrading the Mill's own JVM, which is somewhere here. Okay, I saw it, customizing Mill's JVM. So there's like a .mil JVM version file you can just update to, and it will again download the JVM and cache it somewhere for you. So you don't need to install it globally if you don't want to. You can also install it globally, but it's easier just to update this file and always will download and reuse when necessary. Yeah, and you can try out Zulu or Temurin or Liberica JVMs if you like for various versions. Yeah. Cool. Any other questions? Yeah.
Hi. Could you go back to the slide with the source code, with the line count thing?
Yes.
Okay. So my question is, since these two methods are not this, I mean, they are not. They appear similar, but there's a difference between them because one of them is like functional or functionalish,
yeah,
and the other one is effectful. And does it like require some special handling by the Mill author to do you somehow detect the effectfulness, or you just ignore and just to rely on the safety of this local task test folder?
Yeah. So the rule is you should only write to your own destination folder, and you should only read from upstream destination folders. I guess you read from your own destination folder as well. So within a task, we don't care what you do. You can do mutable state, but as long as within the task you only touch your own folder, other tasks will never be affected. So within a task, this is imperative code, but at a kind of macro level between tasks and at the build level, we can ignore the imperative code within the task because different tasks will never interfere. So as of the current version of Mill, that is purely by convention. So you do the wrong thing, it will behave weirdly and screw up. The next version of Mill, which is due end of June, we have some guardrails in place. So if you accidentally do it, it'll raise an error. And you can override the guardrail if you really want to try and do something unusual. But it'll try to stop you from accidentally mutating upstream tasks destination folders, reading or writing outside the destination folder, because both of those are kind of outside of Mill's safety model. So.
And how these guidelines are implemented?
This OS library, we forked it and just put a bunch of if statement throw exception inside. Yeah, you can get around it. You can spawn a sub-process which won't be safe. You can use Java IO, Java NIO APIs. Those won't be safe either. It's kind of meant to be a best effort thing, and it's not meant to be like a hermetic sandbox like Bazel. Which is why for bigger projects, which really need hermetic sandbox, use Bazel, and then you have an LXC container per task with memory and CPU and network restrictions and everything. So that's for bigger projects, but for smaller projects, it's like less than 1,000 engineers. Best effort gets you quite far. That's our experience.
Okay, thank you.
Yeah.
And I have a second question.
Sure.
It's like super convenient that you deliver so many things out of the box, but I imagine it puts a lot of burden on you as the Mill maintainer and your friends. So aren't you afraid that this model of development will eventually slow Mill development down because you will be responsible of so many things?
I guess there are two answers to that. One is that it's not that hard to define tool chains and plugins in Mill. So it's not really as much work as you'd expect. For example, Mill's Kotlin toolchain with support for Kotlin JS and Kotlin web servers and all that stuff, Kotlin test frameworks, was approximately 1 month of work to set up. You imagine how long it'll take you to set up a Kotlin toolchain for SBT from scratch, or for Gradle from scratch, or for Maven from scratch. It'll be a lot more than 1 month. So it actually is a lot easy to. The ease of use here is not just for end users, but also for plugin maintainers and mill maintainers. It is very easy to just like wire things together and have it work quite seamlessly. So that's one thing. I guess the second idea is putting things in a monorepo or big projects so they can be co-versioned and evolve together. In many ways, speeds up development. There's a reason why many big projects have monorepos. Many big companies have monorepos. Like, no one likes publishing an update and then recursively publishing and updating versions down the entire dependency chain. That just really sucks and wastes time. In monorepo, you don't need to. And the third thing is, just because a repo is big doesn't mean the lines of code per person is big. Like, rather than having 10 repos with 10 people, I have one repo that's 10x the size, but I can also just give other people access. Like, they've been contributing, they seem legitimate, I met them in person, they're not like some North Korean hacker. So I give them commit access and they can push and update stuff as necessary. So there is trade-offs, but I think that it's been quite a decent win. We've been able to evolve mill very rapidly because of this kind of monorepo where everything is tested with every pull request, which is much more difficult in a distributed setup where you make an update and like 5 publishers later something breaks and you have to either back it down and re-publish, and that slows things down considerably, and mill avoids that. Yeah, so it's not easy to maintain a project like this, but I don't think it's catastrophic. It's okay. Yeah. Any other questions?
I have a question. I've noticed you are showing off mill on some Java conference.
Yes.
How was the reception?
They're all scared of Scala, but they are attracted to the other things. So like Scala people might not like SBT, but Java people don't like Gradle that much either. Gradle is also very confusing. It's a different model from SBT, but it's also a very confusing model. Gradle has like 5 DSLs. There's like Groovy, Kotlin, New Kotlin. They have a flat map DSL that kind of copies SBT 0.9 in Gradle now as the newest, and you have the declarative DSL. So yeah, they seem interested. Getting them to use it is a challenge, but we got our first ticket from someone trying to use it in a Java project yesterday that I'm very proud of. So if you go to the mill issue tracker, there is this one. Someone was trying to use it to publish Java this Vaver effect library. So this guy is a Scala fan. I can tell from his GitHub, but this is a Java project and he's experimenting with mill. So I think there is some possibility that we can get Java people to use it. They're not enough with the existing mill tools. One interesting thing that's different from Java versus Scala is that mill is not much faster than SBT used correctly, but mill is 6 times faster than Maven and 3 times faster than Gradle. And SBT is also faster than Maven or Gradle. If you migrated, you would know. But somehow Maven and Gradle are like really, really slow, even though Java compiler is really fast. And that's a quite attractive proposition for many people. Like, hey, you want to wait 2 minutes for code to build, or you want to wait 10 seconds or 20 seconds? Yeah, so the reception I think has been okay, and I think that's one of the big efforts we've been doing to try and broaden beyond the Scala community. It's both an opportunity to get more people to use mill, but also opportunity to get more people to be exposed to Scala and not be scared of it, because compared to Gradle, it's much less scary, and then Scala becomes a safe choice rather than a scary choice. Yeah.
And I guess tomorrow you're speaking at the Warsaw Java.
Yeah, I'm presenting at the Warsaw Java meetup tomorrow. You're going to hear the Gradle versus Gradle Maven pitch, and all the Java programmer pitch, and all the functional programming stuff stripped out, and I'll be presenting it then. You need to treat the sales pitch. You don't talk about effect systems. You don't talk about multi-stage computation. You don't talk about pure functional programming. Talk about object-oriented programming because they love it, and then there's a chance that they might use it. Yeah. Any other questions? Going once, going twice. Otherwise, I guess we're done. Thank you for listening.
Okay, so thank you very much all for attending. Thank you for your talks. And now it's a good time to have some more networking. So before you leave, take some of the food that is left, because otherwise it could go to waste. And then we can sit down. If you go down the stairs, there's a couple of tables. can order something to eat, because beer, drinks, non-alcoholic beverages as well. I'll join in a second. I just need to clean up here. Przemysław sitting here will take you, but it's very easy, just go down the stairs. Thank you very much and see you next time.
Thank you.